All right, so Brian and Nathan, big round of applause. Let them hear you out there. All right.
Check. This thing on? Well, thank you everyone for coming. We are Warner Brothers, and today we're going to talk about what we're doing at Warner Brothers around data science and engineering. So my group today runs the data science and engineering group for Warner Brothers that looks across all of the different lines of business today. Today we have a number of groups that we support. First is theatrical. So everything that we do in box office globally goes through various systems. Last year we did, I believe it was like $5 billion in box office. So who's here is a Harry Potter fan? Anyone? Yes? Awesome. Did you see Fantastic Beasts? Yes? What do you think? Okay, awesome. Cool, so we did Fantastic Beasts, Batman vs. Superman, Suicide Squad. Those were the big ones last year. We also have a very large line of TV. Now, anyone here a Westworld fan? Awesome. Did you know that that was a Warner Brothers production? Probably not. Well, it is. So we do a lot of work where we license our productions to various television stations and cable. So Big Bang Theory is ours. Ellen TV is ours as well. The Flash, all of the CW shows that have the DC superheroes, those are all ours. We were #1 in TV now for the 8th year in a row. On the game side, we do a lot of games such as Lego Avengers, Lego Star Wars. Now, of course, Star Wars and Avengers aren't WB titles, but we license those and put those out within our Lego brand of games. We also did Batman Arkham. Tons and tons of home entertainment, everything from physical to digital as well. So, everything that goes through Amazon, Microsoft, Voodoo, that's all data that we collect and store in our data warehouses. Finally, consumer products. So everything that you see from t-shirts to toothbrushes, those are also licensing deals that, again, are processed within our system. And so when you kind of look at everything across the board, it's just a lot of data, right? We store it, we connect it, we provide these semantic layers, and really that's where a lot of the magic happens. When you're supporting these business units, right, you're building these semantic layers that can tie everything together at a franchise level. So it doesn't matter if it's a weblog, OTT, a point of sale transaction, or it's inventory management. All of this is connected. And really that's kind of where it all starts, but then we start looking at this data and saying, gosh, there's a lot of dark data, right? Data that's not being leveraged to its maximum capabilities. And so when I started at Warner Brothers about 2 years ago, I got really kind of asked the question of how do we scale a lot of the jobs that we're doing today? How do we make sure that we're able to maximize our investments in data and really kind of activate on this dark data? And so one of the challenges came, at least a challenge of scale, was from our marketing department. They had this use case, which was kind of unique in a sense that they were taking these audiences, right, and they had to have these unique counts to understand if consumers visited a Batman versus Superman site, right, how can we collect those audiences and hit our target numbers to be able to market to some of our franchise movies such as Suicide Squad or related Justice League. And so the existing application would take 48 hours just to get a number, right? And what we found is that this was a really great opportunity to leverage the Elastic stack, because Elastic will allow us to be able to do quick cardinality counts to really hit our numbers and prove out that we can go across 10 billion records within seconds versus looking at it from a map produce, wait 48 hours, and then get a number and find out, wow, that's just not, the number I'm looking for. Let me refine that. Let me change some of the queries. Because every time that they ran a query, right, they would make a change whether or not they would, include an attribute, exclude an attribute, but they couldn't, take a 48-hour hit every time. So what we did is we started off with a proof of concept. And so my background, I'll be honest, was Spark and Solar. I had done a huge amount of work on that side 3 years ago. Very successful, but one of the things that kind of resonated with me was, I think towards the end of the project, we were just having a lot of problems with, scaling out, performance tuning, And one of my engineers came to me and was like, gosh, we really should have looked at Elastic, And I said, I get it, but we're too far along. Well, when I started with Warner Brothers 2 years ago, that was the opportunity to kind of just start brand new. And so I was actually here at ElastiCon last year. I met up with Kelly and Peter, who were just great. Gave me a lot of support. Learned about the new product, Elastic 5 Stack, and I decided to say, well, let's give it a try. So back in October, we did a proof of concept, and we started building out the environments and doing a lot of learning. But I started realizing, gosh, this is so much easier and faster to turn around than solar. And at the point where we got to 10 billion records, we started running it, and we were seeing the times that we wanted. And so that gave us, really the confidence to say, all right, let's move this forward. But where we were at that point, we didn't have a team, built out. We're still building a team as we speak, but we wanted to, be able to really kind of partner with a group that would, really understood what it was to deploy at scale, that really had a really great DevOps practice. And so what we did was we partnered with Decision Lab, who I'm going to turn it over to Nathan DeCase, who's done a lot of great work. We heard a lot of great things about the work that they did for DoD, United Health Group, and so it really kind of gave us the confidence to partner with these guys, and it's just been a great success. And so here we go, Nathan.
Sounds good. So at ElastiCon, got to have the architecture slide. Got to show, did a lot of talk of what we wanted to do and what we expect out of this system. So what does that actually look like? So what we can do is start from the upstream sources. Lots of different sources, a lot in the AWS ecosystem, but also there are some things where we want to do enrichment. It may be things that aren't readily accessible via, say, streams or things already put into Redshift S3. So really we're relying a lot on a Hadoop stack to do some of that crunching prior to putting that data into Elasticsearch. This is the set of technologies we're using, as Brian said, not only to reduce the latency of those iterations, to better understand and modify your segments and understand the composition of your audiences, but we also want to make sure that we lower the latency for data coming through the pipe. So we don't want, when we do get answers and iterate over this, we don't want it to be on stale data. So I wanted to make sure we also architect a solution that can bring in data, reliably with lower latency through the system. Lots of Spark analytics developed and deployed on the Hadoop stack there. We also have at the top here, Salt Stack is doing the orchestration. Know that as you deploy complex and highly scaled systems, that O&M and just the amount of work that you invest being an SA ramps up, and it's horrible. You want to make sure that your time is spent getting actual useful answers out of this. You don't want to just maintain systems. You want to use them. So that's why we leverage Salt Stack up there to manage and deploy these components. Make sure we can focus on getting the answers out. And then of course, like talked about, Elastic Stack is a core behind this. It's the brains that make it work. Make sure that we can query, understand segments and composition of those audiences in as near real-time a way as possible. Of course, got the XPack deployed, all the nice bells and whistles that you're typically going to use on something that you want to be stable, kind of hands-free in production. So big pile of curator jobs out there to make sure that things run smoothly and are hands-off for you. And there's also a call out for external data management platform there. So it's wired up to where you do your work, query via Elasticsearch, and we also are closing the loop to be able to push, further downstream and make sure that there are actions taken. So you build, segment, understand the composition of the audience, but you still got to do something after that. And that's where we've wired everything back through to push out downstream and take actions there. I know Brian, he's going to wrap this up with some, so what, results, impacts, kind of what they've been able to accomplish with this.
All right. So once we implemented the full solution with the syndication going from Spark back down to our external DMP, we were actually able to then put this into a production environment, all built out. And the good news is that we were able to convert those multi-day batch jobs into real-time or near real-time, I should say, batches. And reduce the latency of the queries. And that was really the big win, is just, when you look at something like, the entertainment industry, everything that we do is based off of titles, right? So it, really lends itself to text search, right? Being able to put in any sort of, title in, that you can think of, actors' names, different, variations of the titles. Harry Potter, and the Sorcerer's Stone is, in the U.S. is Harry Potter and the Philosopher's Stone, right? And so some of these things, coming from different groups that are now joined back to our weblogs, may or may not be, normalized to the best that we would like. But what we are able to do is leverage Elastic to get that low latency. The other thing is that our campaign ops team has just talked about just how great the system is, because it also allows data discovery, right? So we've now integrated it with the Kibana dashboard, so you can actually now see what your audience is made up of. In the third-party solution, you could not understand the granularity of your audiences, right? You just knew that you put a query in, 2 days later you had a count, and that it would add additional incrementals as they were coming in. And that was just really a problem, because our windows, especially for theatrical, are so thin that you have 2 weeks essentially to market the movie, right? You have 90 days before, 2 weeks after, right? And as you're starting to pull in different audiences from our different websites, you have to be able to react quickly, right? 48 hours, and especially if you don't get the audience size that you want, now it's another 48 hours. Now it's another 48 hours, right? It's ridiculous that it's gone on this long using that technology. So I think it was a really big win to leverage Elastic for this project. One other thing we learned, and from a technology perspective, we used a Murmur 3 hash, and we saw about 50% improvement. So the way it works is that you can either do this at query time, right, or you can do it at ingest time. You do take a hit during ingest, but this is a huge savings for us, because our first iteration with about 10 billion records, and I think at the time we were using I2s about, I think we started off with 9, we went to about 17. We're now experimenting to see if we can do some tuning to use D2s instead, but it was taking about 20 seconds. The Murmur 3 hash just cut that down in half, right? And that was about where the business was comfortable, right? Because the business is always going to say, I want real time, I want it instantaneous, right? But 10 seconds versus 48 hours, there's no comparison. So huge benefits. Finally, before I open up the questions, we are building a very large Elasticsearch team at Warner Brothers. So if you are interested in looking at opportunity as an Elastic engineer, please come see me after the show. I know a lot of people have seen these type of slides at the end of decks. On a lot of companies. The big difference is that we have Batmobiles. So, and I will personally take you to see one if you come in for an interview. Yeah, my word. So with that, if you have any technical questions, overall questions, I think we have a couple minutes.
Yes, thank you. The architecture diagram you showed, why don't you just do everything in Elasticsearch? Like, why do you need all the Spark, all the complexity on the left? I didn't quite get that.
So the reason that we're using the Hadoop stack in there is because the sheer diversity of different sources coming in and some of the more complex joins and enrichments and pulling those capabilities into something where you have one record with everything you need instead of it being in kind of its own pockets and doing it at query time. So investment is done up front to make sure that the end system is much more responsive and complete and rich in the details for those records.
So it's primarily for enrichment.
Right.
And then all the queries are done on Elasticsearch by your customers?
That's correct.
Okay, great. Thank you.
So is that where I'm imagining that if you've got data from multiple sources, it's all sort of in different formats as well, and you probably need to normalize that data somehow, which has also got to be a huge time sink. Is that also Hadoop? Is that where you're doing that?
That's correct. So once sources are brought in, enriched, additional information in there, the normalized form is output onto HDFS in that system. So it gives you some flexibility to replay as well as have historic and do some other kind of ad hoc long-term analysis in that environment if you want, whereas normal workflow and some additional ad hoc via, say, Kibana and Elasticsearch is done if you want, say, low latency visual exploratory capabilities.
So what is the role of Spark here? Can you just not use HDFS and ES Hadoop? What is the role of Spark?
Oh, so the role of Spark is to do that heavy lifting, the enrichments, the joins, the normalization of the data prior to it going into Elasticsearch. So lots of different sources need something to do that in an intelligent way, an efficient way, and we're also using that for the ingest and the loading. So don't have Logstash up there. Logstash is great, but since we have Spark there already, just using the Elasticsearch Hadoop connector there.
Yeah, it was definitely.
Could
We had a lot of metadata, right? So as these weblogs come in, right, they have a lot of IDs that really mean anything from a marketing perspective, right? And so we have to now normalize, add the metadata to enrich it to let the marketing team know that this came from a Batman site and this was part of a DC Comics site versus a owned and operated marketing site for that theatrical title, and all of that kind of has to then be joined up, at a franchise level, right, at a brand level, even at a character level, right, so that we can do, really tighter marketing audiences within that. And so, as Nathan mentioned, right, Elastic is used as the text search and the cardinality queries, right, so you can get those just, a split-second, pivots on your data / refinements, and then be able to really kind of understand what your audience, target would be if you were to send this audience to your DMP and to your ad servers.
My question is a little related to that. So could you elaborate on how you leverage Elasticsearch to find like a set that is related to Harry Potter? For example, because the title varies on different, maybe you have promotion that mention Harry Potter, or the movie is just Harry Potter something. So how do you leverage Elasticsearch to find all of them? Because sometimes people just mention Harry instead of Harry Potter. How do you do the cleanup, or how do you use Elasticsearch to find all of them? Do you basically write a query and tune this query again, then eventually find them, or is there any other way to find them?
So let me make sure I got your question right. So how do we use Elasticsearch to connect the various points that would be related to, you mentioned comic books, theatrical, TV?
Yeah.
Yeah, so what we do is, it's a two-part really process. One is as the data is coming in, right, these are weblogs from various data sets. So, some of them could be our movie sites, some of them could be our TV sites, some of them could be even the studio tour sites, right? At that point, right, we have another layer essentially that allows us, if you look at the diagram, right, the Amazon Redshift, we have transactional databases that hold the metadata, right, the master tables. And then our sites, we have a lot of different IDs, right, that will then tie back up to what we call a franchise management layer that's within that Redshift. So then we extract from Redshift, so data sources come, the log files come down to S3, right, and they just keep dropping, right. We originally were doing streaming, but then the DMP couldn't manage the streaming because they were just too big, and so we're working to change that. So now we get hourly batches, and then those batches now come in. They join up with the metadata layer over in what's called Amazon Redshift, and so then we have a lot of just custom business rules, right, within the Spark transformation. So anything that can tie back to an ID ties back to an ID. Things that can't, right? We actually then will take the web logs and see if there's some sort of a product identifier, and then we leverage Elasticsearch to essentially search across these. So we canonicalize everything from a product perspective. So let's say a Batman TV show and Batman DC Comics comic book, right? The two obviously is Batman is a common thread, right? If they have IDs, you can then start building that up to understand Batman is a member of the Justice League, and so therefore we would be under the Justice League franchise. Versus if we just had a numeric ID, then you're kind of just you don't know what to do with this, right? And so so there's a lot of transformation done at that Spark level, but it's a combination of tying back to IDs of known entities, right? So you can do the entity resolution, and then leveraging Elasticsearch when you can't find an entity resolution, but you do have a text description, and then leveraging that to then tie back so that you can kind of pull all of that into a very simplistic Boolean query, and then package that up. But at the end of the day, right, they want to make sure they understand, if I have a certain audience number that I have to reach, how many unique users are within all of our web assets, so that we can send back to the ad servers.
And I think that's all the time we have. So, thank you. Cool. Another big round of applause.
Thank you.
Thank you, guys.